Okay, we're going to take a look at this visually. What we're doing in this day is we're actually shifting the graphs around. It's got to do with not amplitude changes, not frequency changes. Those give you a basic function, but now we're going to start sliding that graph around the grid, and I'm going to do that. I'm going to try to show you using some technology, using actually my Inspire software, exactly what's happening when we start changing things. You saw on the no slide that the function sets up with some number out front, which would represent the amplitude, some number possibly in with the x, which would represent a shift left or right, and some number at the end, which would represent a shift up or down. We'll call the one inside a horizontal or phase shift, the one inside with the C, and the one at the end is going to be a vertical shift. It's going to bring our graph up or down. So I have some sliders here that'll just change this green function on the fly. You don't see the green sign function right now. I have the original sign and I have a basic sign underneath it in green, but I'm going to use the sliders down this part of the screen to change these numbers in the equation to watch what happens. Well, A represents my amplitude, so I'm going to go grab that A slider and you're going to see what happens to the green function that right now is hidden under the red one. Right now A is 1. Let me drag that and make my amplitude 2. And you see that the peaks and the valleys, the maximums and the minimums, are now going up to 2 instead of going down to 1. I can bring that A, I can turn that A into a 3, turn it into a 4, turn it into a 5, and you see the graph grows accordingly. I'm going to bring it back down to 2. And so now we'll be able to see that green function clearly behind the other one. So all I did was I increased the maximums, I increased the minimums. And so that's just the amplitude change. The frequency change, the frequency is B. The frequency means how many of those cycles I'll see from 0 to 2 pi. And right now on your graph, this is that's half pi, that's pi and a half, that's 2 pi, and we got 4 pi out here. I'm going to go back to this part right here, 2 pi, and I see one cycle, whether it's the red or the green. If I go from the origin to where my arrow is, I see one cycle. But now I'm going to change the green one. I'm going to put a 2 in the place of B, so I'm changing my frequency to 2. And now with the green one, you see 2 cycles before you get to pi over 2. And I'll highlight the green. So we're on the green function here, and my arrow is at 2 pi, and you see 2 cycles. If I bump that B up to 3, you're going to see 3 cycles by the time we get here. So obviously the higher you go with the frequency, the more cycles you will see. That red one underneath still has only 1 cycle. The frequency is 1. So let me drag that. I don't want to change too much at once. I think it's easier to see things one at a time. Okay, I'm going to move on now to my vertical shift, and the vertical shift is at the end of the equation. It's the value represented by plus D. So I'm going to make D a positive 1. And you'll notice that the minimums are still in the same place. The maximums are a lot higher. What actually happened here is I have a new midline. My old midline for the red curve, the sign of X, was the x-axis. The x-axis goes right through the middle of those peaks and valleys, those mins and maxes. But on after I made my midline 1, now you may be able to tell it's the line y equals 1 that is now my new midline. Let me bump it up some more. Let me add let's add 4 at the end of that. And now I added 4, and now these minimums aren't matching up anymore. Well, that's going to depend on what your amplitude is. But if you see a number at the end of the equation, probably the first thing you should do on your graph, once your x-axis is set up your x-axis, and then what you want to do is you want to put a dotted line where your new midline is. So I'm going to go back to Control G, and if I'm adding 4 at the end, or sorry, D is now really 3. So I'm adding 3 at the end. I'm going to put a horizontal line at y equals 3. And now you can clearly see that's your new midline. So instead of using the x-axis to start plotting your points, you'll be using your midline to start plotting your points. If it's a sine curve, you'll start plotting right here. If it was a cosine curve, you'd be going up 2 for an amplitude of 2, but up from the new midline, you'd be going down 2 from the new midline. Okay, so let's bring our midline back down to the x-axis. And we're going to now talk about the phase shifts, which is in the plus C, and that's probably the hardest one to understand. And it's also hard for me to, it's really kind of difficult for me to put anything on the graph because I can't write on top of my Inspire software. But we're going to be taking this black point that's on that green curve, the black point's right at the origin, and we're going to shift everything to the left. Now I'm going to shift everything to the left by, I think I put in pi over 2. Let me just see what happens. Let me grab the C slider. And come on. Okay, yeah, I actually did, I used pi over 2. So where that green dot, oh, it did move the way I wanted to, that's good. So that green, the dot right here that was at the origin has now moved to the left, and it moved to the left by pi over 2 units. So what we have here is a phase shift going on. I'm going to bring the amplitude back down to 1 for that green function. Okay, so now what you can see is we started with the red curve and all we did was slide it to the left. And now we have the new green curve. I'm going to slide it to the left once more, if the software lets me. There we go. I can make some interesting pictures doing this. And if you think about it, if I were to slide it 2 more hops, I just slid it 2 hops. If I were to slide it 2 more hops, what I would end up with is exactly what I started with. That green curve would have shifted so much to the left that it's now right back on top of the red one. And so that's a basic kind of a visual representation of what's going on as we're doing the shifting. So remember, changing that value of D, changing it to a 3, to 3, we'll put our midline at y equals 3, and we'll be graphing from there. Put that back down. A phase shift, changing that value of C, the one that's in parentheses with the X, that's going to result in our graph sliding to the left or sliding to the right. And that sign is working opposite the way you think it is. I'm actually using a positive number for C, and that positive number for C is bringing that green graph to the left. Okay, back to normal for both of those. Remember, B is that frequency, just like it was before. That's just going to increase how many cycles you're seeing. Bring it back down. And that A is the amplitude. And that amplitude is going to be that number above the midline and that number below the midline. If it's a negative, it's the number above and below, positive. The only thing a negative does, and I didn't show you a negative in this graph, a negative there will throw that, will actually create the reflection there. Let me throw a negative in front of here right now and you'll see the reflection. Watch the green line, it's actually going to reflect over the x-axis. And there it goes. And that's really hard. It kind of looks a lot like it started with, but you know that the sine curve, our original, started going up and then came back down. Now our new green one, it's been reflected, it goes down first and comes back up. Okay, let's press on to the graphs that you will have to make in this unit. We'll do a couple of examples. We're going to sketch in the interval 0 to 2 pi, and we're going to, and that's the instruction, so that tells us how to lay out the x-axis. So I can start with a 0 here, and 2 pi, I'm going to use 2 4 boxes. We'll put a tick mark there. 2 4 boxes, 2 4 boxes, and 1 2 3 4. Put 4 tick marks on our graph. I got to go from 0 to 2 pi, so I'll label this one 2 pi. I'll label that one pi. And now this is a sine function, but this says that my new midline is plus 3. So I'm going up to 1 2 3, and I'm going to put a dotted line there. And I'll make it actually look like a line. I'll use the line tool. Okay, so that green line is now my new midline. And so when I go to plot my points, instead of using the x-axis as my center midline, I will use the green line. It's a frequency of 2, so we'll calculate the period. The period is equal to 2 pi over 2, so the period is equal to pi. That means the first cycle is going to end at pi. Okay, this is a sine. And normally I would be right on the x-axis for the start, the finish, and the middle, but I have a new midline. So I'm going to start right here on the midline. I'm going to finish on the midline, and here's my new middle. And if we're graphing sine, then we're going to think about the amplitude. My amplitude here is a 1, so I'm going to go up 1 at the first quarter and down 1 on the third quarter. And now I'm going to repeat the whole process over again for the second cycle. The first, the last, or the start and the end, the middle, up 1 for the first quarter, down 1 for the third quarter. And now again with my pen as best I can, and this won't be great, it's tough with the pen, you want to build that curvature in there. It's tougher to show the curvature, the narrow or the smaller your curves are height wise, the tougher it's going to be to see curvature. But I've just finished the curve, and I want to be sure to label my x-axis, label my y-axis, and write y equals sine of 2x plus 3 on that graph before I move on. And we're ready to go on to example 2. In example 2, we're still sketching one cycle per the, oh wait a minute, the instructions did change. We didn't sketch one cycle on the last graph. We ended up with 2 cycles on the last graph. You take a peek at that one. Let's go back to the second one. Sketch one cycle of, well, we got to figure out what one cycle is. Let's do that. Period equals 2 pi over the frequency. Now if you look, there's an invisible 1 in front of that x. So my period is 2 pi. That means one cycle is going to start at 0 and go to 2 pi. Okay, well, let's start labeling our x-axis. 0 here. Again, we'll count 2, 4. There's a tick mark. 2, 4, another one. 2, 4, another one. And 2, 4, another one. We're going from 0 to 2 pi. There's pi, there's 2 pi. Now, before we stop labeling the x-axis, I want you to take a look at what's in here. And we're lucky that this is a 4 and not a 3. If it were a 3, then I would want to be counting a whole different set of blocks. If it's I've got 16 blocks going on in here. If this were a 3, I'd want to choose a number that's divisible by 3 and use as many blocks as I can. And I think the only way I can do that on this graph is 12, but we'll talk about that later. You might have a homework example like that. So 16 blocks here is going to work nicely because I've got a 4 here, and that's easily 16 is easily divisible by 4. But if that were a 3 down there, 16 blocks would not be a good choice. Okay, so I've got my labeling here, but now I'm going to be shifting pi over 4, and I'm not quite sure where the pi over 4s are. So while I'm at it, I'm going to do this. I'm going to cut pi into 4 equal sections, and this will be 1 pi over 4, this will be 2 pi over 4, this will be 3 pi over 4, and that's 4 pi over 4. This is now 8 pi over 4, and 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Now, yeah, I know these are not reduced fractions, but I think for this graphing, and these aren't final, you know, when you look at those tick marks, it's really to help you position things. So if you start reducing your fractions, you start losing track of your denominators, that's going to throw you. So I'd say, at least for now, just go ahead and use the 1, 2, 3, 4, 5, 6, 7, 8 pi on top and the same denominator all the way across the bottom. Okay, so we've got our phase shift. What does that mean? A plus pi over 4 means this whole thing is going to be shifted left by pi over 4. So we won't be starting on the y-axis. We're going to actually be starting at minus pi over 4. Because we're shifting the whole thing to the left pi over 4. Okay, more considerations, and you'll notice there's a lot of planning going into this graph. More considerations. I have a new midline. My new midline is at minus 2. So I'm going to grab a line and I'm going to make another dotted line down here at minus 2. I'll make that dotted so it disappears a little bit, kind of fades into the background. But it's there for reference. We'll change that to, okay, so that's my new midline down at minus 2. And again, you could put whatever scale you want on the y-axis. I don't know if I labeled my y-axis on the previous problem. I'm just going to go back and check. Actually, we didn't. Yeah, we didn't. I didn't. My bad. 1, 2, 3. I'll label down here 1, 2, minus 3. Okay, and now we can go on to the second screen. Here, back to our problem. So I'm going to label this while I'm at it. I'm going to label this 2. I'm going to label this down here -2. Put a little arrow there showing that's the -2. Just make sure you've got some labels down here. Okay, I've got 2 more things I got to consider. I've taken care of my midline with this dotted red line. I'm going to be centering my graph on that. I'm thinking that I have to start my graph at -π/4, not at 0, like I have in all the other ones. And I'm thinking that, and it's called my phase shift, I'm thinking that it has to be reflected over the x-axis, and I'm thinking it has an amplitude of 3. And there's an awful lot going on, and that's what makes these tough. Each individual part is easy, but the fact that there's so much going on means you really got to pay attention to your detail here. So I'm going to grab a highlighter to start plotting the points here. My first point, let's think about this one carefully. I'm shifting left π/4, so my first point is going to be somewhere over here. It's a sine function, so it's going to start at the midline. So I'm going to put a point there. And then the end of this, that's the beginning of the cycle. The end of the cycle is at 2π. Well, 2π is the same as 8π/4, so I'm going to put my end dot there. Again, my midline dots are going to be on this new red line because of the midline shift. And I'm going to put my center right there. And now I need my amplitude. Well, my amplitude is 3, but this is reflected. So I'm going to go halfway in between those 2 green dots, and I have to go down first. And I'm just going to stop and count the blocks to make sure I'm doing this properly. 2, 4, 6, 8. I've got 10 blocks, so I need to go 5 blocks. 2, 4, 5 blocks from the left, and I'm going to go down from my midline, because that's where all of my start, finish, and middle dots are. So down from the midline, 1, 2, 3. And that's where my dot is. And again, I got 10 blocks here. I'm going to cut that in half. So 1, 2, 3, 4, 5. Let's see if I did that. Okay, right there. 1, 2, 3 up from the midline. And now I'm ready to pick up my pencil and start sketching the curve. I'll use my crayon here. I'm going to start at this dot. Come down, showing the curvature as best I can, up to the middle, up to the top, round it off, come back down. And now I've got a picture of the sine function. A lot of work in that one because there's so many parts to it. But think in terms of your best order. Consider the instructions first. Then you want to consider what the, you'll have to calculate the period, most likely, and then you want to consider the phase shift. And the phase shift is, if there is a phase shift, then you want to pay attention to that so that you can set up all the little fractions in between and make that phase shifting easy for you. Once you do that, when you go to start plotting points, you have to consider, okay, what trig function? Is it reflected or not? And how far off the midline do I go? And you certainly want to put that midline, plot the midline on your point. So again, a lot to keep track of, and that'll come with practice. One more we'll do. We've got, and if you're good to go, you can stop the video here, but if you want to see another one done, just stick around and watch this. It shouldn't take too long. I'm going to begin by reading the instructions. One cycle. Well, I have a frequency of 1, 2π over the frequency, period of 2π. So again, I'm going to start I'm going to be graphing one cycle. Let's label 0 and let's label 2π. But before I do label 2π, notice there's a 3 denominator. So here's where I'm going to use those 12 blocks instead of 16. 2, 4, 6, 8, 10, 12. Okay, there's 2π, which means that pi is going to be 2, 4, 6. But if I've got pi over 3 phase shifts, I'm going to turn all these into fractions over 3. I'm going to make this 3π over 3. I'll make this 6π over 3. That means this is going to be 1π over 3. This is 2π over 3. That's 3π over 3. There's 4π over 3. There's 5π over 3. There's 6π over 3. I'm not going to label them all. But I am going to label this one minus 1π over 3 in case I need it. But notice that the shift in this one is saying minus pi over 3. This whole thing will be moving to the right. Okay, so my x-axis is set up. Label the x, label the y. I often forget to do that. Here's my new midline, plus 3. So let me take a dotted line at 3. I'll move it to make it a little bit more accurate there. Okay, there's my new midline at 3, and while I'm thinking about it, I'll label the y-axis a 3 here and a minus 3 here. And now let's take a look at what how we can start this thing. Well, it's a cosine. It has an amplitude of 2. There's no reflection. So we're going to go to our midline and go up 2, but we're not going to the y-axis because we had to shift 1 pi over 3. So we're actually going to start here. That's the start of my cosine curve. I've shifted to the right by 1 pi over 3. So I'm going to go to the finish, and I also have to finish. The finish also has to be shifted by 1 pi over 3. So this is at 7 pi over 3 where I'm making the finish dot. Again, it's 2 above the midline because the amplitude is 2. Let's go in between those, halfway in between, we're going down 2 from the midline. And then the first quarter, well, I've got 2, 4, 6 blocks. So I'm going to go 1, 2, 3 blocks and go right on the midline. Another 1, 2, 3 blocks and go right on the midline. And it's time to draw my curve. Again, with the curvature and the inflections as best you can. And it'll probably look better on my key than it does on the screen here. Okay, when you get to class tomorrow, you'll be practicing with a few single curves, and then you'll be putting 2 curves on the same graph. And really, it's just all about, there's so much to keep track of, so you really want to go through thoroughly and make sure you did everything you were supposed to do at the end. Do I have an amplitude of 2? Well, it's 2 above the midline, it's 2 below the midline. That looks good. Is it a cosine? Yes, it is a cosine. Has it been reflected? No, but it doesn't need to be. Did I shift to the right pi over 3? Yes, I did. This whole curve, if it were, it's all been moved by pi over 3. You can tell it from the labels. And did I use a new midline of plus 3? Yes, I did. Let's check off a couple of other things just to be thorough. I've labeled my y-axis. I've labeled my x-axis. Let's also write on this function y equals 2 cosine of x minus pi over 3 plus 3. And now we've got a thorough solution here.